Hello, good morning to all my students. Okay, anybody now is online? Now is live watching? Can you give me the feedback? Okay, I want to see anybody here, huh? Okay, we can see. Just type in the chat room, good morning to all. Okay, Celia, morning. Can listen me or not? Hi, Maxine. Okay, Jiaen. Can listen or not? Okay, hi Shiti, no Shakira. Okay, can. Okay, so from here, I want to start with some about your exam first. Okay, the coming, I think the Wednesday lah. Wednesday, I will start about one of the short quiz lah, like this lah. But this one quiz will take about 50% for your midterm. So this one, I just said about the chapter 1 until chapter 3. Chapter 4, I think I'm not including. They just want a objective question in the Google form. So you need to answer within is 1 hours lah. So I will upload in the Google Classroom. So that means the time during my lesson, there's around 11:45 until 12:45. That means you need to finish it. Finish it, remember to turn in. If you never turn in, I don't know you got pass out or not. If you never pass out, I don't know your marks. Okay, so that one is how I want to jot down your 50 marks and also the PPT marks. Okay, PPT will take 50 marks again. So from here, remember, student, so that day we don't have any Google Classroom, Google Meet. So that means you straightforward go to Google Classroom and straightforward do the question. Then after that, the 1 hour, that means you need to finish all the question. Okay, remember, must using the MO email to log in. Okay, we not accepted for the Gmail. And also, please write the full name. Don't simply go and write your name because I don't know what's your name. This one is a serious, so better you go and take serious about this all exam. Okay, after that, so for here, hopefully the student you can get ready for this one, the quiz. So just only short quiz, around 25 question only. So you can do it. I think you can do it lah because the question is almost a simple question. Okay. So from here, I go to start my lesson today. There's about the 4.2. Okay, 4.2 is related also heat. There's under the heat subtopic, specific heat capacity. Okay, let's see what's the specific heat capacity. This one topic quite long a bit. Okay, so I go to separate by part. So I go to part 1 first. Okay, we go to introduce specific heat capacity first. Okay, let's see the one of the diagram here. Okay, the sunny day, you go to picnic. Okay, just like the diagram like this. Okay, different in the temperature of the sand and also seawater at the beach. Although the sunshine, the shine to the water and shine to the land. So you find it, but the temperature at the same time, you find it there's a difference. Okay, so this was one of the thing we need to explain. Why become like this? So you can see for the seawater, the temperature maybe they're not easy to be heat up. But for the land, they already heat up for a longer time. Okay, maybe the time taken, you say, okay, maybe I just let it for 2 hours. Okay, 2 hours you go to test. So you find it the seawater still okay, still a little bit warm. But how about the sand? Sand become very hot already. Okay, so this one is one of the thing we need to explain for these subtopics. Okay, morning for Aisha. Okay, for Muhammad Haika. Okay, so from here we continue for the next part. Okay, I think this one from your textbook. You can refer your textbook. Okay, so they say what? The sand is very hot. So they say this one seawater still cold. Okay, Dylan, morning, huh? Okay, so from here they say the sun will heat up the sand and also the seawater at the same period of the time. Okay, both also at the surface. Then after that, the sun also produce the heat on the surface of the sea and on the sand, is it? So from here they say, however, the sand can get hot faster. Okay, compared to the seawater. Seawater, they get slowly a bit. So from here, this one is a one of the question. So we need to answer it during these subtopics. Okay, so from here, first introduce the sentence for you first. Sand has low heat capacity and also get hot quickly. Okay, while the seawater has high heat capacity and get hot slowly. So from here, the physical quantity need to introduce is a heat capacity. So low heat capacity means what? They gain the heat faster. We call it low heat capacity. So that means when they gain the heat faster, so that means they will hot faster lah. So if I say high heat capacity means they need more heat. Okay, they need more heat to heat up, to warm up. So that means they will hot slowly. So that means the sand is a low heat capacity, means they absorb a little bit, the heat, the temperature increase already. How about the seawater? Seawater is a high heat capacity, means they need to absorb more of the heat. Then after that, they increase the temperature. So that's why at the same time, the seawater, they're still not yet heat up. Maybe just a little bit warm because they're hot slowly. So you get what's the meaning of the heat capacity. So heat capacity, if the quantity is low, mean you faster to heat up. If the heat capacity is very high, mean you take longer and longer time to heat up. This one is the meaning of the heat capacity. That means you need to keep how many heat in the whole capacity. So from here, we go through again more detail. Okay, must go to the heat capacity. What is the definitions? Okay, definitions. Heat capacity, first one, the symbol, we using capital C. Capital C of an object is the quantity of the heat. So it must related with the quantity of the heat that needed to raise the temperature of the object by 1 degree Celsius. That means you want to increase 1 degree Celsius, you need how many heat? Excuse me. If you need more heat to increase 1 degree Celsius, that means you are high heat capacity. If you let just need a little bit heat, then you can increase the temperature. Increase 1 degree Celsius mean you are low heat capacity. Okay, so we go to explain. Okay, just now I say quantity of the heat, then I say 1 degree Celsius means the formula must be related with the heat and also degree Celsius, that's the temperature. So from here, I create the equation for the heat capacity. Capital C equal Q over, okay, can you see the triangle? Triangle, the meaning is a changes. Okay, changes. So changes mean you take the final minus the initial, then we call changes. Okay, so we go to explain. Q is stand for quantity of the heat supply. Okay, delta, this one got changes. Delta means what? Change in temperature. Okay, change in temperature. So from here, we go through unit. Okay, if you want to find the unit for the C, that means Q is a joule, is it? Joule per degree Celsius. So this one is a SI unit for the heat capacity. Okay, so from here you can see the relationship. If the change of temperature is a bigger changes means your heat capacity is low. Okay, so that means you faster to change the temperature. You faster to change the temperature means you're easy to heat up, is it? Easy to heat up means you are low capacity. Okay, just like the seawater. Seawater take longer time to increase the temperature, is it? So that means the changes of temperature not big because you a little bit changes only. If you a little bit changes means the changes temperature becomes smaller. When it becomes smaller, that means the C is a bigger because C and temperature is a inversely proportional. Okay, so from here we continue. Okay, we got one of the situations. Let's see what is that. When 100 joule, okay, now the heat is a fixer. I provide 100 joule to heat the and also the block B. Okay, so now the block B, the experience rise in the temperature 1 degree Celsius, but the block C is 2 degrees Celsius. So from here you can see what's the difference. I provide the heat is the same, but the block C, they can increase until 2 degrees Celsius, but the block B is 1 degree Celsius. Okay, now you tell me which one is a high heat capacity. Okay, the student, you need to answer me which one is a high heat capacity, B or C. Okay, high heat capacity means they take longer time to heat up. Okay, they take longer time to heat up. Okay, so from here, anybody here can answer C or B, high heat capacity. Okay, high heat capacity means although I provide the heat is the same, but it just increase a little bit. High heat capacity. So I'm going to check how many students here can answer it. Okay, amazing. Okay, amazing already enter the class. Okay, yeah, we got answer from Jin Yong Chao, B. Si Liang also B. Ahmad Rayyan also B. Okay, so the answer is B, because B is increase a little bit degree Celsius, although I provide the heat is a more. Is it? So from here, we go and see the next one, explanations. Okay, heat capacity, how to do the calculations. Okay, we show. Okay, C equal Q. Q is 100 joule over 2 degrees Celsius, because changes temperature for the block C is 2 degrees Celsius. So we get the C is 50 joule per degree Celsius. Okay, how about the block B? Block B also same formula, but they divide by 1. So you see this one is 100. So from here, your answer is correct lah. The answer is a B. B got high heat capacity because around 100. Okay, but the block C only 50. So 50 already they can up 1 degree Celsius. But the block B, they need heat until 100. Okay, 100 joule. Then the baru can up 1 degree Celsius. So that means the block B a little bit hard to heat up lah. Okay, so from here we go to answer. Capacity heat for the B is bigger than the heat capacity for the C. So from here we can make a conclusion. Increase in the temperature of the block B is smaller than the block C. Okay, B will slow, slow, slow. Then the C will faster to be heat up. Okay, we got some of the activity here. So the student need to answer me. You need to type in the chat room. Okay, so from here we start with the question number 1. A pail of the water from the swimming pool has been left several hours beside the pool. So we've got 2 water lah. One is in the pail, another one in the pool. So which one water is hotter? Okay, after some time, you tell me which one should be hotter. Pool water or the water in the pail? Okay, let the student go to choose. Which one water will become hotter after some time? Okay, anybody here can answer this? Okay, which water can become hotter? Okay, after some time, you go to let the sun shine to heat up the surface of the water. So you find which one can be heat up faster. Okay, anybody? Pool water. Okay, pool water in the swimming pool. Okay, so suppose I can tell you the answer is no. Sure is the water in the pail. Okay, why? Because the quantity of the mass, you want to heat up the water, the mass is bigger, that means you need to take a longer time. Yes or no? So many water I want to touch. Which one faster to be heat up? Sure, the quantity of the water is less. Pail. Yeah, correct. Jaen. Okay, it's a pail. Water in the pail. Because the quantity of the mass will be affected. Is it? Just now you see the formula. Okay. C equal Q over the changes of the temperature, is it? So from here, one of the thing will affect the changes temperature, there is a mass. The mass is one of the important things. So later I let you to show another example. There's a more clear. Okay, which one water has smaller mass? Sure is a pale water because they just got one of the pale only, is it? Swimming pool is a big part, is it? So from here, we need to make which one water need to be exposed the sunlight in the shorter time in order to raise the temperature by 1 degree Celsius. So that means I want to increase 1 degree Celsius. So which one will in shorter time to be increased 1 degree Celsius? Sure is a pale water, agree or not? Because the quantity is a less. You want to heat the water, quantity less, faster to be heat up lor. So that means the temperature faster to increase. But the pool, swimming pool quantity is a large. So that means you want to heat up by 1 degree Celsius, you need to make whole water, whole quantity of the water heat up first. So the temperature can be increased. Is it? So that means we find it, the pale water, the water in the pail will take shorter time to increase by 1 degree Celsius. Okay, so we continue. Which has the larger heat capacity? So anybody here can answer me? One got larger heat capacity. So larger heat capacity means they take longer time. Okay, they need to keep large amount of a heat. Which one? Water in the pail or water in the pool? They need to keep more heat. Okay, anybody can answer? Okay, yeah, we get the answer from the Lao Guangyuan, Jolin, and also Amir Singh also correct. Okay, Jin Yong Chao. So all is from the pool because pool is a large quantity. So they will need larger heat capacity. Okay, correct. So from here, we go through to the relationship. Okay, what is the relationship? So another one, they're talking about the heat capacity and also the temperature. Okay, now we make a relationship between the heat capacity and also temperature rises. Okay, so what is a relationship? Anybody here can give me the sentence? Okay, if the heat capacity is larger, what do you think about the temperature rises? More or less. So that means just like the pool lah. Okay, the pool is a quantity is a large, is it? So that means the heat capacity, just now you tell me there's a large heat capacity. How about the temperature rises? Temperature rises will be, okay, we're going to wait the student to answer question E. Relationship between the heat capacity and the temperature rises. Okay, is it both also increase or one up, one down, or both also decreases? Okay, let's the student to solve this one relationship. Okay, just now we do some comparison, is it? So that means the student will know how to do the relationships. What means of slow? Okay, I get answer from Xiliang. Okay, Xiliang, give me the answer is the larger the heat capacity, the smaller the temperature rises of the substance. Yes, correct. Okay, correct. So Jaan is high heat capacity, temperature low. Okay, you must mention temperature rises, not only temperature. Okay, must give the rises. You cannot say about temperature low. Rises, temperature low. Okay, so we're going to check the answer. The higher the heat capacity, the lower the temperature rises. Okay, correct. So that means that's inversely proportional lah. Okay, when the heat capacity is higher, the temperature rises, that will decreases. Okay, so I go through to the next activity. Okay, now we're going to see the kettle. Okay, we got 2 kettle. Okay, one kettle P, only 1 liter of water. Kettle Q got 2 liter of the water. So now both P and Q also switch on to heat up the water until boiling means 100 degrees Celsius lah. Which one kettle boil for longer time? Okay, what is the answer? boil for a longer time? Yeah, anybody here? I think there's a no problem for yours. Boil for a longer time. You see the water level, then you know already. Okay, yeah, many of you answer there's a Q. Okay, so Q, that means that's a correct lah. So many here. Nashro, Najiha, also Q. Ngo Kai Guan, what suddenly is here? Okay, so from here the answer Z. Okay, yeah, correct. The answer is Q. Okay, now we go to see the second question. Which one kettle has larger quantity of the heat? Okay, which one is larger quantity of the heat? Okay, okay, so from here, how come working also can see the YouTube? Okay, so from here, we're going to answer B. Is it answer for B? Okay, when you just answer, you go to put the bracket. This one is a question. Which one question? So now I ask about B. Okay, question B. Which one kettle has larger quantity of the heat? So your answer sure also is a kettle cube. Okay, also is a kettle cube because they need more heat to heat up. So they say larger quantity of the heat. Okay, yeah, correct. So from here we go to the next part. Which one kettle has larger heat capacity? Larger heat capacity. Now it's a C. Please answer the question. Answer right in C also. Bracket C. Okay, which one kettle has larger heat capacity? Okay, larger heat capacity. That means they need more time to be increase the temperature. Okay, yeah, Jia En answer me there's a Q. So the answer also is a Q. Okay, so from here we find out already. Q take longer time. Okay, Ahmad, Rian, betul, Q. Okay, so Q will take longer time. Q also got larger quantity of the heat. Q also got large heat capacity. Okay, because of what? Because of the mass lah, is it? So from here, we need to make a relationship between the heat capacity and also the mass of the substance. Okay, how to make a relationship? So normally you want to start the sentence, we just say when. Okay, we mentioned about manipulated first. From here, the manipulator is a mass. Because mass, you can control the water level, is it? So we just say, when the mass of the substance increase, what happened for the heat capacity? So you need to answer me question D, relationship. Okay, when the mass of the increase, so how about the heat capacity? Heat capacity will, okay, so when the mass of the substance increase, mean I'm talking about the kettle Q lah. Okay, when the mass of the substance increases, the heat capacity will, okay, what's the answer? Okay, Jia-En, when the mass of the substance increase, the heat capacity also increase. Yeah, that's the answer. Okay, we go to check. Okay, the larger the mass, the larger the heat capacity of the substance. Yes, that's correct. Okay, Xiliang give me the answer. Okay, Tan Chen Lu also give me the larger the heat capacity, the higher the mass of the substance. Okay, Chen Lu, we just reverse your sentence. We mention the mass first because mass normally is manipulated. The heat capacity we put behind. Okay, the larger the mass substance, the larger heat capacity. Okay, when the mass of the substance increases, the heat capacity will be increased. Also correct. 张燕子 correct. Okay, so this one is how we go to answer lah. Okay, next. Now we go and see what is the factor that will affect the heat capacity. Okay, so from here the student can guess. Now you apply already two activity. You tell me which one should be the first factor will increase or factor the heat capacity. First, we say about the swimming pool, is it? Okay, number two, we're talking about the quantity of the water, is it? So you tell me which one should be the first factor will be affected the heat capacity. Okay, have you think about that? Any idea? the factor will affect the heat capacity. Okay. The mass of the substance. Yeah, that one is one of the thing. Okay, that will affect the capacity. So the first one is the mass. Okay, number two, we can talking about rise in temperature. If the rise in temperature high, that means you very fast to increase the temperature. They also will affect the heat capacity. Okay, so from here the student, correct. Okay, density. Yeah, Kaiguan, density is related with the material of the substance. Okay, so material of the substance, you can say about the volume and also mass, is it? Density normally related with the mass. Yeah, density also one of the part, but the volume also affected. Volume of the water, they also be affected. Okay, so from here we go and see the last one, three. Three is a material of the substance. Different material, heat capacity also different. So example is what? Your pot, cooking pot. Okay, you see the body of the pot and the handle. Different material is it? Which one faster to heat up? Sure, is a pot law, the body of the pot law. Handle sure slow law, because you want to hold it, is it? So when you hold it, you feel okay, still can hold it using your bare hand, but the body already feel hot. So that means different material also will affected for the heat capacity. Okay, so from here you can see, uh, okay, Tan Chen Lu asked, teacher, heat area also can, if your quantity is the same. If the quantity is the same, bigger surface area and smaller the surface area. Okay, first one you can ask about the temperature changes. Okay, temperature changes actually is the same, but you say which one faster to evaporate, which one slower to evaporate. This one will be affected. But you say overall heat capacity for the area is not related. Area is not related. Okay, only evaporation, the area will be affected. Okay, Chen Lu, hopefully I answer your question. Area is not related for the heat capacity. Okay, area not related. The mass must be constant. Okay, the mass constant, one I put inside the small pot. Okay, another one I put inside the bigger pot. That one is a surface area not affected. Okay, only the mass affected. But you say evaporation, evaporation memang got affected lah. Small area very slow lah. Bigger surface area faster to be evaporate. That one is a different things. Okay, so from here we go through this one. You see, okay, surface area memang different is it? But quantity also different, is it? Okay. Okay, quantity also different. One is a bigger size, one is a smaller size. So from here, we can make a conclusion. After being left to cool for some time, okay, the soup in the large bowl, okay, the bigger part is hotter compared to the same soup in the small bowl. So that means you can find the bigger pot, you put the soup inside, is it? So you take out some of the soup in the small bowl. So the small bowl, they faster to be cooled down. You can drink already. You don't tell me you go and drink in the pot, the soup. So that one is a keep high temperature. So that means heat capacity for the big bowl is the bigger. Okay, compared to the small bowl. Okay, so that means the small bowl, they faster to be release the heat. Okay, and also the big bowl, they take longer time to be cooled down. So from here, heat capacity not only say heat up, they also can say cool down. So if I go take two bowl, I go to heat. Which one faster to be heat up? Sure, the small size one, no? Is it? Because the heat capacity low, is it? So if the balik, I go to cool down. Okay, one is a big bowl, one is a small bowl. I want to cool down. Excuse me. Now you're going to see the small bowl. The small bowl, I want to cool down. Sure, faster, lor. So that means I can say low heat capacity. The meaning is easy to eat up and also easy to cool down. That one is the meaning for the heat capacity. Okay, if I say high heat capacity means they take longer time, okay, to be heat up. and also take longer time to be cooled down. That one is the meaning. Okay, so this one is a explanation related to the different mass, then different heat capacity. Okay, we didn't talking about surface area now. Okay, now we're going to see another example. Okay, another example, you see the car. Car got touchboard, then we got cushion, is it? First, two is a different material. Okay, sure, it's a different material one. Okay, so you can see normally during the hot day when you just enter the car, okay, your hand just go to touch your touchboard. Wow, sure, it's very hot one. Okay, but the cushion, you still can sit. Okay, you still can sit because the cushion is a different material with the touchboard. So you can from here explain for you. The touchboard of the car has lower heat capacity they compare to the cushion. So that means the touchboard is easy to be heat up. When they're easy to be heat up, when you just touch, oh, very hot. Okay, compare the cushion. Okay, cushion that means you sit down, you find it or still can sit lah. Okay, but not too hot compared to the touchboard. So from here they say absorption of the heat energy from the sun causes the touchboard to experience higher rise in the temperature compared to the cushions. Cushion also absorb the heat but not easy to be heat up. Maybe long time lah. Maybe you're parking the car there for 6 hours, 5 hours under the sun. Like this, your cushion will be heat up lah. Okay, high temperature lah. So that means it's only 1 hours. I think your cushion still can still okay lah. The temperature not too high compared to the touchboard. Okay, so this one is another thing. Different type material will causes heat capacity also difference. Okay, then we go through to the another example. Okay, you see, why does the watermelon that be cooled down faster than the sandwich, even though both are put in the same fridge at the same time? Both put in, but you find it the watermelon faster to be cooled down compared to the sandwich. Okay, so from here we can mention heat capacity of the watermelon is smaller. Smaller means what? Easy heat up, easy cool down. Yes or no? So that means watermelon that easy to be cooled down when you just put inside the refrigerator. They're easy to release the heat. So you can find it. So the temperature will drop very fast for the watermelon. Okay, compared to the sandwich. Okay, so this one is some of the example lah happen in our daily life. Okay, so we go through. Okay, we need to investigate specific heat capacity. Okay, you can see the different words. Just now is a heat capacity. Now is a specific heat capacity. When I just add the word specific heat capacity, so that means you need to related mass. Okay, now we're talking about mass already. Okay, just now we just said heat capacity. Now we need to we know the quantity of the mass. Okay, so from here I introduce three of the block first. Okay, A, B, C block. First one is the aluminium. They rise by 1 degree Celsius. Okay, another one I'm using the iron block. Okay, also rises 1 degree Celsius. And the last one I'm using 1 kg of the lead block. Okay, also increasing 1 degree Celsius. Okay, now I want to heat it. 3 block also one increase 1 degree Celsius. Now you can see aluminium that heat 900 joule. You need supply 900 joule to heat the aluminium. Okay, the mass is constant. The temperature also constant, but I need 900 joule. Okay, how about the iron? Iron, I only need 450 joule, then they can increase already. Okay, how about the lead box? Lead box, I only need 130 joule, then they can heat up already. Now, anybody here can tell me which one the specific heat capacity is low, very low. Which one? Okay, A, B, C. So you just give me the answer. Which one is a low specific heat capacity? That means easy to heat up. Which one easy to heat up? Yeah, Jaen, correct. C. light box. Okay, the light bulb must be easy because they just only 130. They can increase already. Okay, correct. So many also correct. Lau Kuan Yuan or also Lim Si Liang also correct. Ahmad correct. C. That means from here we find it. The aluminium, there's a high specific heat capacity because they take longer time to be heated up. Okay, so from here I can give you one example lah. If you find the teacher take so long time also never angry one, that one teacher means what? High specific heat capacity, because they need more heat to heat up, then the teacher become angry, is it? So that means when the teacher just angry already, haha, then they need long time to release the heat. So that one the teacher we call specific heat capacity is high. Okay, if the teacher is low heat capacity means what? Very fast. Just a little bit, then the teacher angry already. The one we call low specific heat capacity. So that means the teacher, if low specific capacity, maybe they just faster to hilang lo. Faster to hilang the angry for you. Okay. So this one is a example. So from here, C. Okay, yeah, correct. So from here we continue. So explanations. Okay, different quantity of the heat is needed to rise the temperature by 1 degree Celsius for 3 objects ABC, even though their mass are equal. Okay, so from here, this is because 3 objects are made from the different material. So different substance have different specific heat capacity. So material is one of the things that will affect the heat capacity of the different block. Okay, now we go through specific heat capacity. Okay, which one substance have larger amount of the heat to raise the temperature by 1 degree Celsius? So now you can answer this question or not. Which one have larger amount of the heat to raise the temperature? Okay, just now I asked you is a reverse. I say which one is a low. Now the question they ask which one is a large amount of the heat. Okay, so from here we check from the student what's the answer for activity 3. Yeah, the answer is A. Okay, so correct, the answer is A. So the answer is aluminium. Okay, 1 kg of the aluminium. Okay, they will take longer time to heat up because, and also the increased temperature I want 1, but this one they need how many? They need okay, Chao Yang got answer question here. Is it the substance color also can be affected? Okay, color they will affected for heat absorb. Yeah, they will affected. Black color and the shiny also will be affected. Okay, okay, Chao Yang, Yong Chao, is it Qin Yong Chao? Yeah, the color will be affected the heat capacity to be absorbed. Okay, so that one is a black color and also shiny color also different. Absorb heat and release heat also different. Okay, so from here we still not related with the color first lah. Okay, we just talking about the mass and also the heat capacity. Okay, so we continue. Why the color black is more heated than the other? Because black color they will absorb the heat. Okay, they're easy to be absorbed the heat. Okay, shiny because they can reflect it. They can reflect it, that means the heat is reflected go out loh, never keep into the block. So that one is a different color, got different absorptions of the heat. Okay, so now we go through to the next part. I need to go specific heat capacity. What's the definitions? Okay, specific heat capacity. Okay, you can see what's the different heat capacity and specific heat capacity. Specific, when I just add the word specific, we're using small c. Okay, just now it's a capital C. Now I'm using small c. Of the substance is the quantity of the heat also same. Quantity of the heat. Okay, quantity heat for what? To increase the temperature. Okay, can you see that at one sentence, 1 kg mass? That means now they need to relate the mass. Okay, 1 kg mass of the substance by 1 degree Celsius. Okay, so this one is a specific heat capacity definitions. Okay, now we go through. This one is the formula. Okay, they're using small c. Also same equal to the Q over. Okay, you have to add M. Okay, just now only changes temperature. Now got M. So from here, Q quantity of the heat in joule. M is a mass in kilograms. Then change in the temperature. Okay, if the question never mentioned in SI unit, so normally we're using degree Celsius lah. Okay, unit. Just now it's a joule per degree Celsius, is it? Now you need to add one more. Joule per kilogram per degree Celsius. Or joule per kilogram per Kelvin. Okay, depend the situations lah. Okay, quantity of the heat, there's a Q. There's an absorbed or released by an object can be determined by using the formula. If I want to find about the Q, if I want to find about the Q lah. Okay, this one is find the C, is it? If I want to find the Q, you can using the formula MC data. Okay, MC data. So normally we never mention about changes lah. We straightforward say Q equal MC data. So this one is a heat energy formula. Okay, so we continue. So this one is a one of the info to tell you. Heat capacity using capital C. There's a Q over changes temperature. But specific heat capacity, they're using C, small c, but they need to relate it with the mass of the object. Okay, so that means mass of the object is a one thing that will affect the specific heat capacity. Okay, we're talking so much already, so we need to answer some of the question. Okay, what's the meaning for the specific heat capacity of the metal? Aluminium is 900 joule per kilogram per degree Celsius. Okay, this one sentence actually what's the meaning? Okay, we need to answer. So like this, we can write. Okay, the meaning is 1 kg, because they say per kg. See, per kg means 1 kg lah. 1 kg of the aluminium that needs how many joule? 900 joule of heat. Okay, of the heat to raise the temperature of 1 degree Celsius. So I mentioned the mass, I mentioned the temperature. So this one is related for the definition 900 joule per kg per degree Celsius. So we need to answer like this. Okay, if I give you one another sentence like this, what means for specific capacity for the water 4,200? How you go to make the definitions? So the definition, we just change aluminium. Aluminium help me to change become water. Need how many joule? 4,200 joule of the heat to raise temperature by 1 degree Celsius. The rest is the same. Only you change the object, then you change the joule. So this one is the definitions. So from here you can see 1 kg of the water that needs 4,200 joule of the heat to raise the temperature by 1 degree Celsius. Okay, so hopefully the student understand this 900 joule per kilogram per degree Celsius actually is what's the meaning. So we just count all is a 1 kg and 1 degree Celsius. You need using how many joule? 900 joule. Okay, we got one example question. So we fast forward because we just left. Now it's 15 already, 50 minutes lah. Okay, a matter of the mass 2 kg. Okay, a matter of the mass 2 kg. Calculate the amount of the heat. Question, they want Q. They must be transferred to the metal to raise the temperature of 30 to 70. Okay, they want to heat up. Excuse me. The object from 30 to 70. Then the question give you give you the C. Okay, specific heat capacity. That's 500 joule per kilogram per degree Celsius. So I write the info first. Mass 2 kilograms. Temperature, remember, changes. Don't take 30, don't take 70, but you take 70 minus 30. So there's a 40. Okay, C is how many? 500. So the question want to find Q because they say calculate amount of the heat. Okay, so we just let the student to answer. I show the formula. Q equal MC data. Okay, student, you can type here. What's the answer for Q? Okay, what's the answer for the Q? Okay, we just apply all the thing, put in the formula, then we can get the answer. Okay, don't forget the answer got unit. Okay. Anything? Russian? Question mark, what's the meaning? Okay, so we get the answer from Xiliang. Okay, 40,000 joule. Okay, 4,000 joule. So we go to show. Okay, we just put in all the info. 2 multiply 500 multiply 70 minus 30. So we get the answer is 4 times 10 power of 4 joule. That's a 40,000 joule lah. I just write in standard form. Okay, I think this one no problem. Student must be understand the question, must write the info, then you can apply the formula. Okay, excuse me. Okay, we try to the example 2. Okay, example 2. How many joule of the energy are required to raise the temperature 100 gram of the gold from 20 to 100? Okay, from 20 to 100, then the object is 100 gram. Okay, then now the need is how many energy required. Okay, specific heat capacity is 129 joule. Okay, per kilogram per degree Celsius. We also write info first. Okay, the info mass, you help me to change kilogram because this one is not, I'm confused when we put kilojoule or joule. It's the same. You want to put joule or kilojoule is a okay one. Okay, yeet lah. So you can see the question, you can write in kilojoule. When you put kilojoule, that means you need to divide by 1,000. No? After divide by 1,000, you can put kilojoule. Okay, if you never put kilojoule, that means you put 30 behind. No? So normally don't put kilojoule, we put joule. Better. Unless the question they want put kilo. Okay, example just now answer is okay, I go to pin. Just now the answer from Xiliang is 40,000 joule, is it? So you can write 40 kJ. 40 after put kilo joule. That means you hilang that 30. That 30 stand for what? Kilo. Okay, understand? So if you're not so familiar to put the prefix, so you no need to put. You straightforward put 40,000 then joule. Okay, that's a simple. Okay, the answer from Xiliang, which one should be the correct? 1032 joule lah. Okay, so we go to get it. Okay, so we apply the formula is the same. So 0.1, I change the 100 gram become kilograms. So 0.1 multiply 129. 129 is a C. Then changes temperature is 100 minus 20. So I get it. The answer is 1.032 times 10 power of 3. So that means if you never put in standard, there still is 1,032 joule. Okay, so like this, you can see this one. If I put kilo, is okay one. 1.032. So I no need to put this one prefix lah. The power, I straightforward put kilojoule. They're also correct. Okay, so from here I go number 3. Okay, 8.4. 10 power of 5 joule. Now the question already provide the heat. Okay, raises the temperature of 4 kg of the water from 40 to 90. What is specific heat capacity of the water? So from here, the info. Okay, mass 4 kg. Okay, then the heat 8.4 times 10 power of 5. Then the increased temperature is a 50. Now the question they want to find C. Not Q already, it's a C. So from here I show the formula. Just now it's a Q equal MC data, is it? Now I want to find the C, so I go to change. Now C equal Q over M data. So all is the same. Put all the thing in. So what you think about your answer? Okay, any student can be answer me? Oh, here is raining heavily already. So I don't know the line can be support or not. Okay, any student? Any student can be applied, not only Xiliang. Okay. Okay, Kaiguan. Kaiguan give me 4,200. 4,200 is what? Okay, Joe? Why got Joe? Unit from Xiliang. There's a capacity. Specific heat capacity unit. Okay, so we just apply 8.4 times 10 power of 5. Okay, not Joule. The question now never ask about Q. They ask about the C. You got to check. C is what unit. Okay, 8.4 times 10 power of 5 over the 4 multiply 90 minus 40. Okay. Okay, so from here we just see the answer. Why got 42? Okay, 4.2 times 10 power of 3 joule per kilogram per degree Celsius. So this one is the correct answer. Okay, 4,200. Remember, this one not Q. They ask about heat capacity. Okay, they never ask about energy. So you must remember now the unit is a difference. Okay, the student don't be catched by the question. Okay, must be read carefully. Okay, so the last part is very important, a little bit hard so you listen carefully. Now we need to learn about mixtures, mixed together. Now you can see the diagram. We got milk, mix the coffee, maybe the water, you want to mix the coffee. Okay, now we're going to see. Whenever, Yan Zhiyan ask me the mass is no need to change the gram. Change to gram. Must change. Gram must change become kilograms. Okay? Okay, must change SI unit. We cannot say we're using the gram because joule already is a SI unit. We cannot say per gram. We don't have any unit is per gram. We're still using kilograms. Okay? So from here, why to change to gram? I just answer your question first. Okay, they give me the question like this. Okay, teacher, the mass no need to change to gram. The unit SI unit is kilogram. Why you need to change become the gram? Okay, must using kilogram, not using gram. Okay, if the question they give you gram, you need to change back to kilograms. Okay, so this one is what I can answer you. Okay, you see the mixtures. Whenever the two material they are different temperature and also thermal contact. Thermal contact, contact together. So the hotter material will lose energy, is it? By transfer to the cooler one until both achieve thermal equilibrium. Remember this one situations? When both liquid are mixed together, different temperature, is it? When it just mix together, then you wait a while, the hot will release the heat, then the cool will absorb the heat, is it? After some time, they achieve thermal equilibrium. So from here, what we can say about that, they are mixtures. When they just achieve thermal equilibrium means finally the milk add in the coffee, both will mix together, finally the temperature must be the same. Agree? Because already is thermal equilibrium. So I can write the equation is a M1 C1 data equal M2 C2 data. Quantity of the heat already is the same because equilibrium. Heat absorb, heat release already is equal. So I can put the equal at the middle. MC data 1 equal MC data 2. 1 is what? Liquid 1. 2 is what? Liquid 2. Okay, now we're talking is what? Liquid. We never say solid add the liquid. Different thing, that one. Because the solid you need to melt. This one we never say about the melting. We just say both is a liquid. When they just mix together, the heat, when they just achieve thermal equilibrium, must be equal. Okay, equal to transfer. Number 2, the temperature must be the same. Okay, so from here, M1 stand for mass of liquid 1. C1, specific heat capacity for the liquid 1. Example, coffee. Okay, if C2 is what? Specific heat capacity for the milk lah. Okay, data 1 is what? Data 1 means the coffee changes temperature. If I say the coffee is a hot coffee, that means later the coffee will cool down lor. Agree. If I say the milk is a cool milk, so that means the milk later there will be warm up. Okay, so from here we continue to the next part. Next one must be serious to see this one question. Okay, 0.2 kg water at 100 degrees Celsius mix 0.25 kg water at 10 degrees Celsius. First, we feel there's a safe for capacity. The question never provide capacity. Why? Because both also water. When both is a water, when you put equal, actually we can cancel each other. Okay, now the question they ask you, what is the maximum temperature reached by the mixtures? When they just mix together, finally, when they just achieve thermal equilibrium, what is the temperature? So I can tell you the temperature sure between 100 and 10, agree or not? Because 100 they will lost, then the 10 they will up, between, but we don't know how many. We cannot divide by 2 because the mass is a different. Okay, this one 0.2 kg, this one 0.25, so we cannot divide by 2. Okay, so we need to show about the info. M1 0.2 kg, M2 0.25. Okay, data 1 is how many? 100. Okay, data 2 10. Okay, data F means what? Final temperature. After the mix, how many? Okay, so from here I need to show the equation first. Just now what you see about the equations. Okay, from here which one we can cut? The C we can cut because both water is the same. Specific heat capacity for the water and water sure is the same one. Unless you say water and also milk, that one is a difference. Okay, we need to do the calculation. But this one, no. They say both also water, then we just cancel heat capacity. Okay, one more thing. Just now you asked me gram and kg, is it? For this one situation, you got equal, is it? So if M1 using gram, M2 also using gram, and we no need to change kilograms. Okay, because later both also cancel. If M1 is a gram, M2 is a kg, you need to change. Like this, you need to change. Okay, if both sides is the same unit, it's okay. Never mind. Okay, so now I need to find is the final temperature, is it? So data 1 is what? Data 1 is for the 100 degrees Celsius. Final temperature sure less than 100. Agree, Data 2 is a 10 degrees Celsius. Final temperature sure more than 10 degrees Celsius. So I can write the equation again. So you check carefully. M1, C1. Data 1 is 100. 100 minus final temperature will be equal M2, C2. Final temperature minus 10. So what I need to find? Final temperature. Okay, now I got 2 equations already, is it? So that means I put all the info in. 0.2, okay, and 1. Data 1 is what? Data 1 means degrees Celsius minus final temperature will equal 0.25 M2. Final temperature minus 10 degrees Celsius. So that means we sure will know final temperature sure less than 100. Final temperature sure more than 10, is it? So from here, 2 equation, you need to solve it and find what is the data F. Okay? So I think this one is not physics problem already. You can use your max method to do the calculation for the final temperature. Okay, you just take the 0.2, you just multiply in the circle, in the boxes. Then this one 0.25 also put in the bracket. Then you go to multiply. Okay, so from here, the time is coming soon, time's up. So I go to show you the, you can do calculation also lah, because you can check the answer. So from here, I can show you 20. This one 0.2, I multiply 100 become 20 lah. So minus 0.2 data F equal 0.25, I put in 0.25 multiply data F minus 10 multiply 0.25. So become like this. Okay, second step. Okay, now the third step you need to change. Okay, the 2.5 you move to left hand side, then the data F you move to right hand side. Okay, Amira, give me the answer is 42. Okay, we go to check what is the 42. Okay, now 22.5, 22.5, because I move this one to right hand side, is it? This one go to right hand side, becomes 0.45 data F. Finally, I want to find data F, is it? So data F equal, oh, so wrong already, Mira. They know about the 42. That's a 50 degrees Celsius. Means I take 22.5 over 0.45. Is it correct or not? I got to check. Oh, Ahmad give me 10. Why there's a 10? Over 0.45. Yeah, there's a 50. Okay, Celia, you can get 50 or not? Okay, Celia? Celia, are you here? Celia go already. Okay, my time already finished, coming soon already. So I still got the one of the last question. Yeah, Celia get. So 50 degrees Celsius. Okay, so final, last. Give me some time. Okay, 300 gram of the water at the temperature 40. Mix 900 gram. Okay, both also water, both also gram. So we just ignore. No need to see about the gram, no need to change. This one is a 80, one is a 40. When it just mix together, sure between 80 and 40, is it? So from here, we just write the equation. All the info, 300, 900, 40, 80, then we do no final. So from here, we go to show. Okay, question is the same. So we just put 300 gram. Okay, final temperature minus 40. Final temperature sure more than 41. Equal 900. 80 minus final temperature. Okay, so from here we just put all the 300, you go to multiply in the bracket. So I get the number like this. Okay, I continue to do it. Okay, so from here that means 72,000. 12,000 you put to another side, so I get 84,000. So this one is a 300 data F, 900 you move to left hand side, become 1,200 data F. Finally, data F is how many? Okay, 70. Is it logic or not? Logic lah, because 80, 40, you are 70, you at the between, inside, okay, inside the range. So that means now the answer should be correct. Okay, when you get the answer, you must think your answer logic or not. If you get 90, that means 90 wrong already. How come got 91? 90 means already over the temperature, more than the higher temperature of the water. Okay, so this one is one of the question for the mixtures. We need to do the calculation like this. Okay, so the 5 example already finished to explain for you. What you need to do is the Google form for your attendant. They got 5 of the question about specific heat capacity. So when you just log in, they need the code, the lesson code. The student, remember when you do the Google form, I will take it as a PPT also when you get the marks. But I ignore the code lah. The code just want to know you got listen or not. So the code from here today is a number 9037 hashtag. Okay, help me to type there. 9037 hashtag. Okay, anybody here can type that? 37 9037. 9037. Okay. 9037 hashtag. Okay, 9037 hashtag. Okay, anybody here can type that? 9037 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037. 9037 Celia can type or not? Oh, yeah, correct. Okay, I go to pin, eh? Okay, 9037 hashtag. Okay, yeah, correct. No spacing, don't do the spacing, and also don't copy paste, you need to retype in the Google form. Okay, so the Google form will open until 2 o'clock. So because maybe you got class already, I open until 2 o'clock. 2 o'clock I will lock it. So this one is for your today attendance. Okay, so thank you for your watching, and remember to download in the Google Classroom. I upload already the lesson 4.2, okay, together with the tutorial. So you can print out and try to do the exercise. Okay, every student, our lesson just until here. So hopefully you understand. If you do understand, you can PM me to ask. Okay, bye.